Have you heard the term serverless for the first time? Are you confused in like what exactly this term means in terms of computing? You have like questions on, okay, if it's serverless, then where on earth are servers? Do they actually exist? And how will our application work? This video is exactly for you. So first of all, we'll look at what is a server with some typical examples. Then where does this serverless concept came from? I've given an interesting example of a Butler. Then we'll go ahead and see how it works and how it handles the load. What are the limitations? What are the pros and cons of serverless applications, and when not to use them. So let's get started. A server is nothing but just another computer that is good at sharing information with other computers. It's like a boss computer in a network that listens to the requests from smaller computers, also known as clients, like desktop, laptop, or a phone, and sends them the information they need. For example, when you search for something on the internet, your request goes to the server. The server then finds the answer and sends it back to your device so you can see it on your screen. Remember that the server computer needs to be powerful enough so that it can fulfill the request from the clients. As an example, if you look at this Facebook server, consisting of multiple computers joined together so that they can serve billions of users. Another example would be a very small local computer. You have set it up in your home. This could be a desktop PC that is serving few clients. Whereas if you don't want to manage the hardware on your own, you can also spin up a virtual server, for example, Amazon EC2 instance. Again, this does not mean that there is no hardware at the back end. Well, actually there is. So Amazon actually assigns a small piece of its compute to this specific EC2 instance that you are paying a fixed price on monthly basis, whether or not you are utilizing this server or not. That was a typical server example. Now let us move ahead on the serverless concept. But before that, I would like to explain you from where this serverless concept came by giving you an example of a butler. Let's suppose you have a guest house and you have one butler, and this is being treated as a resource with a fixed pay of $3,000 a month, and its tasks are making the food, cleaning, and welcoming the guests. If you look at his monthly activities, we can see on January he was being utilized most of the times, whereas in February and March we didn't have much guests, so that's why he was mostly sitting idle. So paying him this amount for January was really worth it, but not on February and March, and he still got $9,000. Whereas think of another scenario where we have a company that provides the butlers at a fixed rate of $15 per hour. And we hire the butlers from this company on the need basis and pay them accordingly. As an example, on January, we utilized him for 25 hours. We paid $3,000. On February, we paid $720 for 6 hours. And on March, we paid only $240 for 2 hours. So in total for 3 months, we just paid nearly around $4,000. So not only this is cost effective in this terms like pay as you go, but also we are saving other costs like butler's accommodation. Now you may ask, what advantage does butler provider company has in this? Just like our guest house is utilizing their butlers, similarly, there may be many other companies that are taking their services. So they are in business as well as we are also being cost effective. Now let us put this same concept into the computing world and see what exactly the serverless means. We have some cloud provider companies like Amazon and Azure who are providing compute resources that can fulfill our business logics. So let's say you have a task that trains the data, and you're also telling that this task will require at least minimum of 512 MB of memory. You submit this task to the server that will do the job for you. This also provides a plus advantage of not being worrying at all about the infrastructure of the server, how it will run, and especially how it will manage the load. Because what happens at the back of the scene is you can throw in as many serverless tasks as you want. The cloud provider's serverless architecture will gonna make sure that each of your tasks is being run in parallel. So it assigns a dedicated compute machine to your task. And each of these compute machine is running in one of their server racks. As soon as your task finishes, the compute machine dies. Till here you still may be asking like, okay, there are actual servers at the back of the scene, then why do we call it serverless? Well, the answer is that it's serverless for you because you don't manage that server. You're not paying for that server full time. You are just utilizing the cloud provider servers for only that time that you need, and you will be charged for only that specific amount of time. Speaking of their limitations, so serverless platforms often impose limits on CPUs, memories, and storage, which can be limiting for certain applications. As an example, I have mentioned the numbers of AWS and Azure. Another one is that these serverless applications typically have a maximum execution time, making them unsuitable for long-running tasks. Another is it has limited debugging. So unlike in your Java applications where you can set up a remote debugger, you cannot do this here because you don't own the servers. So the only way to debug and monitor your application is just by looking at the logs. Speaking about the pros and cons of the serverless, so first is its pay-as-you-go nature. So you only pay for the actual compute resource used during the execution of your task, which can be cost-effective for variable workloads. You don't need to worry about provisioning, managing, or maintaining the server. The cloud provider handles all the infrastructure tasks for you, so that you can focus on writing code with, as I explained in my previous example, that it can instantly scale up and scale down based on the numbers of incoming requests, ensuring the optimal performance. Speaking about the cons, serverless functions may have a delay in responding to the request, known as the cold start, which can affect in the initial response time. Serverless functions are designed to be stateless, as I showed you in my previous example, like all of the tasks are running in parallel. No single task has any information about the other task, which can complicate the management of the persistent data. Serverless platforms offer unique features that may be vendor specific, potentially tying you to a particular provider ecosystem. This makes it difficult to switch the providers if in case you want to in the future. Serverless applications are and should ideally be used in like event-driven tasks. The tasks that are short in duration and do not require continuous server resources, like an application responding to an event or a trigger in a scenario of webhooks, IoT data, database changings with real-time processing. It's also ideal to use in small applications which are part of a microservice architecture. It's also being said to use serverless where your application experiences varying level of traffic. In that case, serverless can automatically scale to handle the load spikes. And where not to use the serverless architecture is where you have consistently high workload. In that case, it may be more cost effective to use a traditional server-based hosting. For tasks that require execution time significantly exceeding the maximum allowed by the serverless platforms. For applications that require subsequent CPU, memory, or GPU resources that may not be available in serverless environments.